Hello everyone, this is Siddharth, and in this video we will be solving another question from the list that I have shared in the starting of this playlist. So if you don't know that I am making a playlist on my YouTube channel where I will be solving all those questions which are related to each other, so that we can able to memorize all those standard processes and method, and we will able to build pattern so that we can able to retain those concept for long period of time, and we can use those concept and method and the pattern that we have built during this playlist to solve all the other question uh, that that we will be getting asked in the interviews. So let's start solving this question. So that is 581 on LeetCode, that is shortest unsorted continuous subarray. So we have given this array and we have to find that shortest subarray. If we will sort that subarray, then the whole array will get sorted. Let me explain it to you. So let's take this array as an example, 2648. So array is 2648 and then 10, 9 and 15. So 10, 9 and 15. Now what we have to do? We have to find the longest subarray so that if we will sort that subarray, then whole array will get sorted. So that will going to be this in this case, because this 15 is the highest element and this 2 is the smallest element, and these all our elements are between these two range. So now we can say that this is the smallest sub array. uh, if we will able to sort this array, then this whole array will get sorted. So now the final array will look like 2, then 4, then 6, then 8, then 9, then 10, then 15. And what we have to do, we have to return the length of the shortest subarray. So how we can solve this? Obviously we will be using two pointer approach here as well. So we can assign a left pointer here and the right pointer here. Then we will move into deeper into the array until unless this is the, like, if we will able to find the next greater element. So this will going to be 6 here. So now a left will point to this, and right will point until unless we will able to find the smaller element than this element. So right will be pointing to this because this element is greater, so we have to stop here. Now for this remaining array, what we can do, we can find the maximum and the smallest element. So why we are doing this? So let me tell you. So first, this is the greatest element and this 4 is the smallest element. So after finding this, now what we can do, we can like short, we can expand the boundary from the left side and from the right side. Why we are doing this? So suppose if we will able to find any element which is smaller than this left side, left element, and the any element which is greater than this right element, then we have to uh, mm, then then that element that we have find, they should present at the boundaries. So that's why we can extend this window so that we can accumulate these the element that we have just find, which is the smallest and the greatest element, and those are the greater than this one and the smaller than this element. Then we have to accumulate that in the starting and the ending. That's why we have to increment the boundary so that after sorting, this element, the smaller element, will be occupying the place of 2. Suppose we have find 1 here, then this 1 should be present here and 2 should be present at the place of 4. But if we will constrain the boundary up to here, then we can't accumulate that. So that's why we have to expand the boundary from the left and right. So this is the concept that we are using. Now let's code it out as well. Okay, so first we can make two pointers. So int start is equals to 0, and then int end is equals to nums dot length minus 1. Now let's define the size of this nums array as well. That will going to be nums dot length. And now first what we have to do, we have to find that element which is which will break the condition, like which is smaller than its previous element. For that we can do like that. So while this left value is less than n minus 1, and another condition will going to be nums of uh, or let's define it as left, and this is as right. Okay, so while this left is less than n minus 1, and the value which is at the current index, so nums of left should be smaller than, less than or equals to nums of left plus 1. So if this is the case, we have to increment the left value, and now we have to handle the base case as well when the array is already shorted or there is only one length we have given for the array. So for that we can find it as, if this left value is equals to the length of the array minus 1, then we can return 0. That's what we are given here. And now let's do it for the right as well. So while this right is greater than 0 and nums of right is greater than or equals to nums of right minus 1. So while the nums of right is greater than nums of right minus 1, then we just have to decrement a right pointer. So right minus minus. Now we just have to find the minimum and the maximum element in the remaining subarray. So for that we have to define these two elements. So int minimum so far is equals to math dot minimum, or sorry, integer dot max value. Okay, now let's copy paste as well. So this will going to be int max so far, and this will going to be minimum value. Now let's use an for loop to find the minimum element so far and the maximum element so far. So this I will be starting from the left value, and this I should be less than the and equals to the end value, because we have to access the last element as well, and then I plus plus. So we just have to update these values. So min so far is equals to math dot minimum of the current value min so far and the element which is present at the ith index. So nums of I. Okay, now let's copy paste it for the max so far as well. Now this will going to be a and x, then math dot max of min so far, this will going to be max so far, and this will going to be nums I. Now we just have to extend the boundaries that I have told you, that if we have encountered any element which is smaller than this element, then we have to increment the boundary from the left and right side. So for that we can use another while loop. So while this left, as we are decrementing from the left side, then we have to check for that this left should be greater than 0, and let's take another for loop that will be handling for right. So this right should be less than, as we are going from the right to the right side for incrementing the boundary, so this should be less than n minus 1. Now this, for this left condition, the another condition will going to be we have to stop only when we have encountered the element, or we can say we have to run this while loop until and unless we are finding the element which is greater than the minimum value. So for that we can use nums of left, if that is greater than the value that is going to be minimum so far. So if this is the case, then we have to decrement the left value, and for the right value, what condition we have to apply, that nums of right should be less than. So we have to increment the boundary until unless we have found the element which is smaller than the maximum element that we have found in the remaining subarray. suppose we have found 16 here, then we have to increment from the right side. So we can use if this nums of right is less than or equals to max so far. If this is the case, then we have to increment the right value, and now we just have to return uh, right minus left. So this will give us the length of the subarray. So if you want to calculate the length of these numbers, then you can, or if you want to calculate the between numbers, then you can use this right minus left plus 1 to calculate the value. Okay, now let's try to run this, and so this should be right, not end. And let's see if we have defined it again, left left right right. Okay, now let's try to run. Okay, so there is a mistake, let me see. Okay guys, so the error is this nums of left, this should be nums of left minus 1, because we have to check for the previous element, not for the current element, as we have already checked it for it. And this should be right plus 1, and then I have done it by mistake, right minus left plus 1 to calculate the length. Now let's try to run. Okay, so let me check. Okay guys, so this should be right, should be greater than 0, because we are decrementing the right value. So we have to check whether we have uh, exceed to the negative indexes. Now let's try to run. Okay, let's try to submit it as well. Okay guys, so the issue is, as we have to return the shortest array, for that we don't have to consider this equal, because it will uh, keep track of the repeated element as well. So that's why the issue is coming. Now we can submit it. Okay, so we have successfully solved this question. See you in the next video. Bye.